Hey, Algebra 2. We are not necessarily moving on from functions. We will pretty much never move on from functions the whole year or function notation, but we are going to move on from transformations to something else. Your requirement for this assignment is to fill out the notes while you're watching the video. So make sure that if you type it directly on the doc, or you can print it and write it, or you can write it in your notebook. I don't really care as long as you are physically taking your own notes. So just submitting a picture of my screen is not acceptable. You need to watch the video in its entirety and upload the notes to get credit for the assignment. Remember, the video is, you're watching this through Edpuzzle, so I will know how much of it you watch, how long of it, and things like that. So make sure that you are actually following along, taking notes as you're watching the video. We are going to talk about function notation. Like I said, it's never going to go away, so we're going to make sure that we understand it really well. I know I reviewed it at the beginning of this unit before we talked about transformations, but it's going to keep coming back, so I want to do another little recap of that. And then I am going to talk about something new-ish. It's called operations with functions. I actually think you're going to be happy with it. It's not that difficult, so the video shouldn't be too long. So let's jump into it. We have some definitions here. I just recalled the definition of a relation, which is just a set of numbers. And more specifically, a function is a set of numbers for which every input has exactly one output. So for functions, we have no repeating x values. So, we talk about the vertical line test and things like that. So it says, in the past, we have seen equations in the form of y equals. We know that, we're comfortable with that. Y equals some sort of equation, whether that's y equals 2x plus 5 or y equals x squared or y equals the square root of x. We have seen that. But function notation simply means, function notation. Simply means that we replace the y equals with f of x. For example, the function notation of y equals 2x plus 5 would just be f of x equals 2x plus 5. They're the exact same thing. Don't let function notation scare you. Okay, they are exactly the same. You should be getting more and more comfortable with function notation. So it says, note here, f of x should be considered a symbol and does not mean f times x, right? So it is not representing multiplication. Okay, so that not is really important. It reads as, so there are two ways to read this. We know that we can say it as f of x. But what that really means is the value of f, so the value of our function, or the y value, at x, right? So that means the value of f at x. What is the y value at that particular x value? In function notation, x is still your input. So therefore, if you have f of 2, you would just substitute it in for any of the x's. And remember, when we substitute, we always use parentheses, always. Also in function notation, if you're given like f of x equals 2 or f of x equals a number, that just means y equals that number. So you need to set your function equal to that value and solve for the input. Again, this should be all pretty much review for us here. So let's see. So I've got two examples here. It says, let f of x equals 7 times x. So it says, find the value of f of 4. So that means we substitute 4 in for x. So I'm going to have f of 4 equals 7 times 4. 7 times 4 is 28. So f of 4 is 28. And basically what this is saying is when x is 4, y is 28, or we can have the point 4, 28. And I can put anything into a function. So if you're not understanding that, like I can ask you what f of smiley faces, and it would just be 7 times smiley face. I can ask you what f of heart is, and I would get 7 times heart. I can sub anything in for my function notation, for my input. So then here it says let f of x equal to 5x to find the input, to find the value of x. So, sorry, let me slow down here. It says let f of x equal 5x. To find the value of x, if f of x equals 15, we set 15, or we set 5x equal to 15. This is the output. It is our y value. So it goes, we just replace this with what it equals. And then we solve. So in order to solve this, I would divide both sides by 5. So x would be 3. Again, I can sort of do this for anything, right? If I said f of x equals heart, then I would make this heart equals 5x, right? I'm putting the heart where f of x was, not just the x, but the whole thing. So that should be review. That should be a really quick, just kind of overview and reminder of like function notation. So it says we can do a lot more with functions than just find inputs and outputs. So in the earlier part of this unit, what we just finished up, what we just had the quiz on, we created new functions from parent functions by performing certain transformations. So we started off with a parent function, and if we, shifted it up and shifted it left, we've created this new function. So the whole point of this video and starting this unit is other ways to the rest of this unit is other ways to create new functions. You can always make new functions out of pre-existing ones by performing different operations on them, and that's what we're going to talk about today specifically. So operations of functions. So this says let f and g be any two functions, and really what that means is f of x and g of x. A new function h, or h of x, can be defined or created by performing any of the 4 basic operations on f and g. So basically what that means is I can add f and g together, I can subtract f and g in a different order, I can multiply them, or I can divide them and come up with some new function. The same way that I performed transformations and came up with new functions, like I said earlier, I can do it with the operations. So I'm going to talk about some notation and some definitions, mostly just notation. But here, so for addition, if I wanted to create a new function h of x, all I would have to do was add f of x and g of x together. I could also do g of x plus plus f of x. That would not get me a different answer when I'm adding. Remember, if I'm adding the operations, I can switch the order and it won't change the answer. You might also see that you can have the notation here where they might note like f plus g in parentheses and then put the of x. It's the same thing, it just means add the two functions together. So if I have f of x plus, if I have f of x be, let's see, x plus 2, we'll keep it simple, and g of x be x minus 7, and they asked you to add f of x and g of x, I would just take what f of x is, which is x plus 2, and take that and add it to what g of x is, which is x minus 7. And then I'm going to combine my like terms. So, x plus x is 2x, and then 2, positive 2, and negative 7 make minus 5. So my new function here would be 2x minus 5. And that would be your h of x. You've created a brand new function out of 2 other ones. I can do that with subtraction as well. So here, if I wanted to create a new function, I can do f of x minus g of x. That is not the same as g of x minus f of x, you will get a different answer here for subtraction. So they're not the same. Also, you can see it in the form that I wrote up above. They might give you like f minus g of x. Same thing, it just means subtract the two. So in our particular example here, I'm going to have f of x, we'll do f of x minus, we'll do both. We'll do minus this way and we'll do it the other way so that you can see the difference. So if I'm going to subtract g from f, so I'm going to write down my f of x, and then I'm going to subtract, and I need to put g of x in parentheses because I want to subtract the entire function. So I need to subtract each part of it. So that's why I put it in parentheses. And then I'm actually going to distribute that negative. So it's going to be x plus 2 minus x plus 7. Then I can combine my like terms. X minus x goes away, so I have nothing. And then 2 plus 7 is 9. So here I would just get 9, which would just be y equals 9, which would be a horizontal line. It's a constant, so not too fun of a function. Let's see if I subtract the other way. I want to show you that you don't get the same thing, whereas maybe we'll go back and subtract and add g and f and see that you do get the same thing. So again, when you subtract, you're not going to get the same answer depending on the order that you subtract in, so make sure you do the correct order. So this is going to be x minus 7 minus parentheses x plus 2. And then here I'm going to get x minus 7 minus x minus 2. And combine your like terms. So again, x minus x cancels, so it looks like I might get something similar, but then negative 7 and negative 2 gets me negative 9. So it is not the same function. One is a horizontal line at 9 and one is a horizontal line at negative 9. So very different. Well, not very different, but not the same. Here, but if I go back and I add them in the opposite order, it's not going to make a difference. So this would become x minus 7 plus x plus 2. And again, this still gets me to x minus 5. So order doesn't matter for addition. You can make a note of this here if you'd like. For subtraction, order does matter. And you also need parentheses around the second function every time you use subtraction. So we can talk about multiplication too. So for multiplication, I'll have the new function will be f of x times g of x, or you might see it where they write it as f times g of x. So those both mean multiplication. So for me to multiply f of x times g of x, I'm going to do x plus 2 times x minus 7, and I'm going to double distribute here. It's probably been a while since you've seen this. You might also see it called as, I believe I taught it to you guys back in freshman year as FOIL, means first, outer, inner, last. And what that means is you're going to multiply your first term times your first term. So x times x is x squared. Then you're going to multiply your two outer terms. So that's going to be minus 7x, because it's x times 7, negative 7. Then you're going to multiply your inner two terms. So I'm going to do plus 2x, and then I'm going to do my last term times my last term, which is going to be negative 14. And then I'm going to combine my like terms to simplify this down all the way to become x squared minus 5x minus 14. So essentially what I've done here is I've created a quadratic function by multiplying two linear functions together, which is, I think it's really cool. But you guys might just be like, oh, Rosaki, this is just ridiculous. But it's interesting to see how different functions create new ones. So that's f times g. If I did g times f, I would get the same thing. So I'm not going to show that. And then division is going to be the easiest one here. There's not much we can do with it because we don't know enough yet. We will learn more about division of functions later in the year. So for our purpose now, this point in the year, when we divide functions, we're just going to write like f of x over g of x. You might also see it as this notation. Let me move this. So you might see this, f over g of x, same thing. What's not the same is if you switch it upside down, right? 2 divided by 4 is not the same as 4 divided by 2. So you could also have g of x in the numerator and f of x in the denominator. So there's bunch of different ways to create new functions. And like I said here, the simplifying where there is none. So for my two functions, if I have f of x over g of x, it's just going to be x plus 2 over x plus 7. I cannot, sorry, x minus 7. I keep doing that. So x plus 2 over x minus 7. You can't simplify. You can't cancel the x's here, because it is a binomial. So I cannot divide the x's here. It does not work. There's nothing to simplify. There's nothing to add. There's nothing to subtract. I can't do anything. That is just my final answer. And same would be true for if I flipped it upside down. So can't simplify. I would just leave it like that. So that's performing the basic operations on functions and how you would create new ones. So I encourage you to pause the video and try the next 6 and then see if you get the same answer. Right, so here we go. They want us to add f plus g. So I'm going to take my x minus 5, which is my f, and I'm going to add that to my g, which is x squared minus 3. The only like terms here are -5 and -3. When you write your final answer here, you should write it in order from highest exponent to lowest. So this is the proper final answer of f plus g. That would be our new function. So we've added those two functions together to get a new quadratic function with 3 terms. Here they want us to subtract, so I'm going to take my f and I'm going to subtract g from it. Remember, I need to subtract the whole thing, so I'm going to put the second function in parentheses. I then need to distribute the negative, so it's going to be x minus 5 minus x squared plus 3. Combine your like terms. Again, my only like terms here are -5 and +3. X squared is not a like term with x. So highest exponent to lowest, I get this function. Two very different functions. They are quadratics. They have 3 terms. We will talk about quadratics way more next unit, but for right now, you just need to be able to recognize that that is a quadratic because it's x squared. Here it wants me to multiply them. So I'm going to do x minus 5 times, I don't even need to write the dot, times x squared minus 3. And again, I'm going to double distribute, or what some of you may know as FOIL. So I'm going to do the first times the first. X times x squared is x to the third. So this is x to the third. Then you're going to do x times -3 to get -3x. Then I'm going to do -5 times x squared, which is -5x squared. And then lastly, we're going to multiply -5 and -3, which is +15. Please put it in order from highest exponent to lowest. So my final answer here is going to be x to the third minus 5x squared minus 3x plus 15. So I multiplied together a linear function, right? X minus 5 is linear, and then I multiplied it with a quadratic, x squared minus 3, to get a cubic. A cubic because the highest exponent is 3, so then that made a cubic function. Just a few more. So here I'm doing f divided by g, so f of x would be x minus 5. G of x is x squared minus 3. You cannot simplify. I cannot cross out any x's. There's nothing I can do. That is just it. I cannot simplify those. For here, they want you to do g of x minus f of x. That's just, don't get tripped up by that notation. It's nothing too special. It just means g minus f. So g of x is x squared minus 3, and I'm going to minus the whole function f of x, so I need parentheses around it. Distribute our negative, leaving us with x squared minus 3 minus x plus 5. Combine our like terms, and we're going to be left with x squared minus x plus 2. Notice how this one and the one above it are not the same, so changing the order of subtraction changed the function entirely. And last but not least, here we are going to divide g of x and f of x. And that just literally means write the g of x function on top and the f of x on the bottom. Here we cannot simplify. We don't know how. We will learn at some point during this year, but right now there is nothing else for us to do with division. And that is how we create new functions out of a combination of multiple functions. So I can add, subtract, multiply, and divide functions to create new ones. Make sure that you go back if you need to fill out anything that you might have missed. If you have questions, write them down so you can ask them in class, and I will give you practice in next class.